Q-qPCR software tutorial, Creating an Assay. An assay contains information regarding the target amplicon or amplicons when multiplexing, the Q-PCR conditions, and analysis type required, along with various analysis parameters. Once an assay is set up, it is stored in a library from where it can be located and added to any future run. A new run can begin by simply selecting the desired assay, which contains all the information to achieve both the run and analysis. To create a new assay, select the New icon. Select Assay. Let's start with Assay Setup. First, the Information page. The Information page gives details about the assay based on the chemistry. There is a list of different chemistries from which to choose: intercalating dye, hydrolysis probes, dual hybridization probes, molecular beacon, and Lux primers. The selected chemistry will set the remaining defaults. Let's look at a couple of examples. Intercalating dyes. Start by naming the targets used. There can only be one target when using intercalating dyes. Give the target a name. Describe the target in a few words. Enter the amplicon length in base pairs. Provide a name for the forward primer, and enter the sequence for the primer. Then add the same details for the reverse primer. Select the type of dye you are using. The dye selected will set the channel used. Only the chemistry type, target name, and dye are required to be completed. All other information is optional. Now let's take a look at the Profile Editor. The Profile Editor sets the conditions that will be applied during a run. A default profile is provided based on the chemistry type. The Profile Editor is comprised of initial holds, cycling, melts, profile summary, and volume control. Modify the profile to meet your conditions. You may change by double-clicking the name of a hold step. Names could include reverse transcription or UNG. You may change temperatures, change time in minutes and seconds, add another hold, change the name, temperature, and time. The dye selected on the cycling section will set the run channel. The correct channel will automatically be selected if the information section has been completed. You can edit the number of cycles, remove a cycling step, change cycling temperatures and times. In the melt section, you can modify the melt conditions, change the melt temperature range, and modify the melt ramp rate. Use a low ramp rate for high-resolution melt, or HRM curves. Enter the reaction volume required. The volume range is 5 to 30 microliters. Time to run completion is also shown. Select Analysis to set parameters for the target, then set the analysis type required. In this example, we will use relative quantification. Select the gene role. This target is a reference gene. Finally, save the assay to the assay library. Save the assay under a specific name. Repeat all steps to also create an assay for the gene of interest. The assays will be ready to be used in every run. Hydrolysis probes. Under the Information tab, select hydrolysis probes from the chemistry type. With hydrolysis probes, we can now multiplex targets. The Q-qPCR instrument is a 4-channel system that allows multiplexing of up to 4 targets per assay. Add a second target by clicking the plus Targets button. A second target will appear below the first. This process can be repeated for up to 4 targets. Enter the first target name. Enter an optional description of the target and the amplicon length. Include the primer name and sequence for both forward and reverse primers. In our example, we are going to be genotyping the HSV target. Therefore, we need 2 probes, one for each allele. To do this, select the Contains Alleles box for the option to add a second probe that is specific to the target. Let's add our second probe by clicking the plus Probes button. Now enter a name for the first probe. Importantly, select the reporter dye at the 5' end. The dye selected will set the channel used in the profile. As an option, enter the probe sequence and select the 3' quencher from the drop-down menu. Enter the details for the second probe. Copy and paste to simplify sequence editing. Introduce the new SNP to the second probe. Enter the name of the second target and all the optional information. As with the previous target, the second target is also looking for different alleles. Enter the details for each probe. Select the reporter dye and all other optional information. Make sure the reporter dye for all the targets and alleles are different. Now let's take a look at the profile. The default profile is based on a common hydrolysis probe assay. When required, adjust the parameters according to the assay design. The channels used are set by the dyes we selected in the information page. In this example, all 4 channels are used. Gain adjustment values are defaulted to a setting typical for hydrolysis probes. Finally, we select the reaction volume we want to use. Now, let's set up our analysis parameters. We do this for each target. For the HSV target, we will set the cycling parameters. Due to the accumulative nature of the signal for hydrolysis probes, it is best to choose a dynamic method of baseline correction. We can also choose to ignore the first 5 cycles for baseline correction. However, a parameter such as this might be best determined during assay optimization and therefore applied at a later time. Let's change the parameters for the VZV assay too. Finally, save the assay. In this video, we have quickly shown you how to set up assays on the Q-qPCR software for intercalating dye and hydrolysis probe chemistries. For more information about these and other assay chemistries, please contact your Quanta Bio team.